This is Exeter Math 3, page 26, number 6. The question is to find the polar coordinates for the point described by x equals 4 and y equals -7. So the first thing I'm going to do is just graph 4, -7. Be about right there. Now this is in the regular Cartesian coordinate system, which basically just has an x and a y that goes left, right, up, down. So this is right 4, down 7. Okay, what we're looking for is the same point where it would be in the polar coordinate system. Now the polar coordinate system looks a lot like the one on the right here. So instead of having a left, right, up, down, or horizontal, vertical movement, we actually have a radius and a angle theta. So for instance, a good example would be this point, say right here. We could call that radius 6, 330 degrees, because that's our angle there. And you can think of that radius there. So that's the idea. That's the basic concept here. So this same idea holds true, but we're going to try to do it in the Cartesian coordinate system. So the first question is, what's the radius from the origin of 4, -7? And again, we are looking for r, theta would be our polar coordinate point. So to find out for 4, -7, we can find the radius pretty easily, either distance formula or Pythagorean theorem. So that would be square root of 4 squared plus 7 squared. So that's going to be r equals. So r equals square root of 16 plus 49, which is 65. And I'll just leave that as square root 65. So our coordinate would be root 65, comma, now we need what theta would be. Now what theta is our angle from the positive x-axis, so we need this angle right here. Well, that angle is a little hard to find, but we can find this angle from the positive x-axis down by using our arctangent function, or inverse tan. So we can do arctan, or inverse tan, of opposite over adjacent, so 7/4, and that'll give us our blue angle right there. Okay, making sure I was in degree mode, I got that angle equals 60.26, and that is this angle right in there. So that means that the angle we use for red there would be 360 minus 60.26, which equals 299.74. And that would be our theta. So our final point is root 65, comma, 299.7. I'll leave it 299.7.